Hi, we're NeuroMap. I'm Barrett Andrews.
I'm John Toby.
I'm Mohammed Musa, and we're a capstone engineering team at Arizona State University working with Mayo Clinic.
During neurosurgery involving motor or fluent regions, awake neurosurgery is often used to determine the location of the different regions of the brain. These regions are incredibly important to the surgeon to know because causing any harm or damage to any of these regions might impair the person forever. Traditionally, a neurosurgeon will use an electrode to stimulate the brain in order to identify the different regions. Once each region is identified, the locations are marked using a simple, sterile piece of paper. This is a big problem in neurosurgical procedures. These papers are often misplaced and often washed away during irrigation.
The goal of the NeuroMap device is to combine cortical stimulation with stereotactic navigation techniques to digitize the tagging process. This method will allow greater accuracy, more efficient tagging placement, and greater flexibility in the shape and distribution of these tags. Tags will be applied using a custom tool which contains both stimulatory electrodes and tracking hardware.
This process is demonstrated here. First, the novel cortical stimulator is used to apply a tag to the surface of the head. Then, the user switches to a tracked bipolar cautery. When this tool encroaches upon the tagged region, the user receives visual feedback in the form of a color change on the navigational interface and an auditory alert. Haptic feedback has also been implemented. Another tag is created and feedback demonstrated again. This allows the surgeon to navigate traditional neurosurgical tools while receiving heads-up alerts about the position of the tool with respect to tagged areas. In addition to tag information, the system provides a traditional stereotactic interface displaying DICOM information in 2D and 3D reconstructions of patient anatomy.
2 experiments were run to validate the accuracy of the system. The first investigated the number of reflective markers and the overall length of the tool. This experiment demonstrated that the final tool will track with sufficient accuracy during intended use. The second utilized a 3D printed phantom and a corresponding DICOM set to demonstrate that registration accuracy was within acceptable ranges and was robust to user input errors.
An additional prototype was created to investigate user perception of haptic feedback. Using this prototype, the optimal parameters for pulse sequence and amplitude of the haptic feedback were determined.
The target market for the system is neurosurgical devices. Based on the number of glioma and epilepsy resections conducted each year in the United States, which are the types of neurosurgery in which awake neurosurgery is the most commonly utilized, a conservative estimate of the device market is about $765 million annually.
By combining cortical stimulation with stereotactic navigation, we bring integrated functional region mapping into the modern neurosurgical environment.
This unique combination of proven neurosurgical techniques will allow awake neurosurgery to be conducted more efficiently, safely, and effectively.
Thank you for taking the time to watch this brief overview of the NeuroMap cortical stimulator.